Hi there, and welcome to another episode of The InEVitable. This is MotorTrend show about the future of the car, about the future of mobility, about the future of flying cars, or in this case, electric taxis.
Air taxis, electric vertical takeoff and landing vehicles. First up, an explainer. Why is Ed on Zoom? Why is he dialing a remote? I have COVID.
Yes, COVID.
I tested positive, came back from Pebble Beach with it. That was a week ago, still testing positive. So out of an abundance of caution, I did not want to infect Johnny. I did not want to infect our lovely guest who came all the way in from the Bay Area for this. So I'm dialing in remote.
And
not
our guest
ideal.
is Oliver Walker Jones from a company called Joby. Now, who's Joby? They're going to make these air taxis, electric flying copter airplane things. And it is apparently a multi-trillion-dollar industry that's about to blossom. And so without further ado, here is Oliver Walker Jones of Joby. All right, welcome. We have Oliver Walker Jones from Joby. They're going to make these things called EVTOLs.
eVTOLs.
eVTOLs, all right. And they're electric vertical takeoff and land vehicles. And I think our question, Ed, is... where's our flying cars? We've been promised, we collectively as a society, flying cars since the 1950s. Where are they?
So I was going to say, I think it's actually, dude, where's my flying car?
Dude, where's my flying car?
But they're coming, and they're coming surprisingly sooner than people think. I would say the first thing to get off our chest is it's not a flying car. It doesn't drive on a road.
Right.
But it does resemble a car. It's the same kind of size. We kind of compare it to an SUV. So there are 4 passengers in the back. There's a pilot up at the front. This thing's going to take off. It's going to fly you to your destination, a range of about 100 miles. And it's going to get you where you want to go through the air. And hey, that's basically an air taxi or a flying taxi.
So everyone knows what we're up to. So Joby, you're going to manufacture these, and there's a bunch of people. Again, eVTOL.
That's
the correct way to say it? So an
or an air
eVTOL,
taxi.
Or an air taxi. But there's a lot of companies, corporations, including, like I was reading, Toyota and Boeing and Embraer down in Brazil. They're all trying to get into this market. So this is happening.
Yeah.
And you say sooner than we think. So where are we at?
So our aircraft's been in development since 2009. That's when our founder CEO Joe Ben Bevitt came up with the idea, started the team, and started working on a design of an aircraft. The technology kind of caught up, things like batteries, computing power, all caught up to make this a reality. And so, we started flying full-scale prototypes back in 2017. We've done that a bunch of times now, and we're kind of on the last stage of this now. The technology is basically proven out. So we're targeting commercial service launching in 2025.
2025,
yeah.
So a year and a half from now.
That's it.
So, and yeah, this is fascinating because what's the disruption here, right? Because VTOL, vertical takeoff and landing, has been around for forever. It's been, I remember as a kid, Harrier jump jets, right? Like that was like the cool thing. Like the Marines had this plane that could take off and land on the air. I'm sorry, on the ground or on a carrier. Is it that it's electric, or that you're making a service out of it, that you're building them? Like where, like we're trying. This is really interesting because we're trying to wrap our head around this as a concept.
Yeah. So I mean, you're bang on. The conversation that I often have with people is, I explain what it does. It takes off vertically. It flies you where you want to go. It lands again, and they're like, "Hey, you all just invented the helicopter again." But it's right. Particularly different, and it's different for a couple of reasons, and they all relate to the fact that it's electric powered. So if you start with an aircraft that's electric, it allows you to do several things. And the most important of those is that you can distribute the power across the airframe. So instead of having one rotor like you might on a helicopter, one main rotor, you can distribute that power using electric cables across the aircraft. So we have 6 rotors on the aircraft. And what happens when you divide that one rotor into 6 is you reduce a lot of the noise profile that goes with it. And so now we're talking about an aircraft that can land in and around our cities incredibly quietly without annoying the people who live there. So that allows you to kind of go and land right in the middle of a city maybe, and deliver a service which people have never really imagined before.
Because helicopters have been around forever, but they are noisy and expensive and all those things.
Yeah.
But in cities, they typically land on the very tip tops of buildings. They don't really. When they do land in the park, it's an event. I've seen a couple of medical things where a helicopter's coming and it's wild. The rotors themselves. I mean, they knock your hat off. It's very disruptive. And I'm assuming you're saying that the Joby 6 propeller thing won't be nearly as disruptive to everyday life as like a big bell or a Euro chopper or something coming down, right?
That's exactly right. So we normally say seeing is believing, but you kind of have to have hearing is believing for this one. So if you come and you listen to it and you're standing 100, 150 feet away, it sounds like the sound of the wind in the trees. You can continue talking to the person next to you. You don't really notice it taking off and landing.
We saw Ed hit me to this video. We saw it was, I think you guys put it on YouTube.
Yeah,
and it was two airplanes, like a Cessna and I forget the other one, Crier or whatever, and then 3 different helicopters, and then the Joby, all flying over the same spot, and it didn't show the decibels, but it showed like the
waveform,
of the noise, and I mean it was I'd say like an order of magnitude or so quieter than the gasoline powered.
But let me ask.
Vehicles.
So that's nice and all, but is that an actual limiting factor to these things, like scaling as a company? Are noise complaints like this? I'm totally unaware of. Like, were you guys? Is that like you could not launch a service like this with like a cheaper helicopter just because the noise would limit you?
Well, if you consider cities like New York and LA today, there are helicopter services. There are companies like Blade that will take you from Manhattan over to JFK, but they are so rare, and they're rare because they're very, very noisy. And there are organizations in New York like Stop the Chop, which exist to try and protect the communities from the noise of helicopters. But more than that, if you use electric power, you also get serious cost saving.
Right.
So
helicopters are very expensive.
Yeah.
For a lot of reasons. I mean, one, they're scarce. I mean, the idea. I assume part of the ideas, one of the ideas behind your company and companies like yours, is that you're going to scale. So, in other words, you're not just going to have, I don't know, I don't even know how many helicopters are flying around LA. Like, maybe on a busy day, 50 between police, news copters, and private copters.
Yeah.
And you want thousands or tens of thousands in major metropolitan areas. Is that correct?
I mean, one day, yeah.
Okay.
We're going to start small and we're going to grow that. But
sure.
There's no reason why you can't have many, many, many of these in the skies. And so the scale is definitely going to help with the cost. But when you break it back, it's actually the underlying technology that makes the biggest difference. So if you have a helicopter, very, very complex machine, thousands of parts, lots and lots of single points of failure.
Yeah.
And that's really where the cost comes in. So, I often describe a helicopter as it's a set of parts that are constantly trying to pull themselves apart from each other. The whole thing wants to separate. And there are lots of little strong bits that are all holding it together because it's complex, it's mechanical, and there's an awful lot of force involved. Now, if you use electric power, you don't need gearboxes. You can generate the torque using the electric motor. You don't have single points of failure. With 6 rotors, you have all sorts of redundancy built in. With electric, you can spread your batteries out so you get redundancy again. And so actually the maintenance
that's
profile,
interesting. So in other words, like with a car, electric car, you'd have like essentially what's a single battery. It's a bunch of cells that are all linked together, and we know that like if a couple cells fail, it still works fine. And that's sort of the same idea with an electric aircraft. Is that you could actually have like parallel batteries.
Mm-hmm. Exactly.
Interesting, because I know I with a helicopter, I mean single motor, single failure, but also single fuel tank, single failure.
Yep.
Okay.
Yep.
Interesting.
And that that high number of single points of failure mean that the maintenance burden on a helicopter is really, really high. You have to take it apart, look at it, replace the parts very often because the safety standard is high, right? And so they have to avoid any chance of failure, and therefore they're always down for maintenance, right? Being checked and making sure they're safe. Now, we get rid of a lot of that, but we also get rid of a lot of the parts that go into it. It's considerably simpler to use an electric propulsion system if you can design it.
I mean, it's the same as true as cars. You throw away
as true as cars, right?
throw
Something
away
like
the
40%
transmission.
fewer parts, right?
Yeah,
Like that,
throw away
everything.
valves and all that.
Yeah.
Okay, cool. So we've seen.
But wait, hang on. With one of the things that is the enemy of both cars, and I imagine for anything flying with electric power, is the weight, right? Like that is like comparably sized. I think I read your Joby, the 6-rotor vehicle. It's a pilot and 4 passengers.
That's right.
Is that correct? Yeah. So then, how does that compare to a helicopter that can carry a pilot and 4 passengers? Roughly the same weight? Is it lighter than?
Yeah, I mean the aircraft itself is way lighter than a helicopter of comparable payload, and we're able to achieve that for a bunch of reasons. Part of it is the mechanical simplicity, but a lot of it is actually the innovation that goes into how we've designed the vehicle itself and the materials we're using. So it's a carbon composite fuselage. The entire aircraft, basically the wing and the fuselage, made from carbon composite. And we've tried wherever possible to drive weight out so that we can get the aircraft to the maximum range, because everything with the payload relates eventually to the range of the aircraft.
Sure.
And so we plan to take those 5 people up to 100 miles is what we intend to deploy the aircraft on. And that's really what's going to make a difference for us. Is the lightweight nature of the aircraft is critical to commercial success at the end of the day.
What speeds do you fly at?
So the aircraft's going to fly at up to 200 miles an hour.
Like off the bat, like that's not like that's the top speed, but we're going to dial it back to 100 or something?
No, there'll be operational reasons why from time to time you'll go a little bit slower. But the aircraft for sure goes to 100 miles an hour. We've flown it faster than that already. We've kind of proven it out in our test field.
Because I mean, I don't know much about helicopters, but I know that a freaky fast one is around 200, and the normal. I've been on a lot of helicopters in my strange career, but about 100 knots seems to be where they fly at over populated areas.
Yeah, well, the key difference here, and you kind of have to go look at the YouTube film to get this bit, but when the rotors tilt down, so the 6 rotors lift you up vertically, then they tilt down, and when they tilt down, you're flying forwards. It basically becomes an aircraft,
right,
with a fixed wing.
Okay.
So it has a wing, and the wing is providing the lift, and therefore you're able to get a lot. You're using those rotors just for forward momentum, much more than you're using them for lift, which you would in a helicopter.
Okay, got it. So, oh, interesting. Okay.
Yeah.
So that's great. I like 200 miles an hour. That's good.
And it's in a straight line. That's the most important thing. You jump in an Uber in Manhattan, you go to JFK. Goodness me, you go a long way around.
Yeah.
If you do it in an aircraft, you might have to dodge one. Another aircraft will go through a certain bit of airspace, but you're basically going in a straight line. So the time saving is really the value prop here.
So I guess my big logistical question is, you mentioned Manhattan, and they're landlocked in terms of there's no more space. Real estate is at a massive premium. Where are these things going to go? Same here in LA. I mean, we have it's spread out, but it's built up. Like, I'm trying to think like, okay, if I wanted to take one of these from my house, I can't even maybe a park. Like where you know what I mean? Like where?
Yeah. So
that seems like a real problem.
Yeah, so for sure, we're going to start with existing infrastructure. So, around Manhattan, there are 3 or 4 helipads that are situated around the shoreline of Manhattan. Same at LA, all of the major airports you can fly helicopters in and out of.
Sure.
And then
there's lots of regional, just, LA, Van Nuys, Santa Monica, which they're trying to get rid of, but Santa Monica, Hawthorne,
Hawthorne
a bunch
Airport,
of
where
regional
Tesla design is.
Yeah, but the real magic comes when you start to unlock other locations.
Yeah.
So
talk about that.
Let's go to a football stadium. Large car park, large flat surface,
right.
or a
Dodger
center.
Stadium.
Yeah, right.
Okay.
Or a shopping center that has a flat roof, or a parking structure of which there are hundreds, if not thousands, in the city. Reinforce the top deck, stick a single landing pad on the top, and you're away.
So you said reinforce the top deck. How much does the Joby? What's it called? The first product. What's it?
So we're calling it the Joby aircraft.
Joby. How much does that weigh?
So you're looking at thousands of pounds.
What about how many thousands?
Up to about 5,000, 6,000.
Oh, so it's the same as a pickup truck.
Yeah.
Oh, so it's not. It's not. So you don't really need to. I mean, I guess you shouldn't have to do that any reinforcing.
Yeah.
Because parking structures, I guess the roof, you would never put a car on the roof.
Well, yeah.
No, you would. Yeah. Okay.
Yeah, sometimes. I mean, what you'll come to learn is with the aviation sector, huge amount of regulation and guidance. So
right.
there's a
so you want to
significant.
you want to have it 3 times as strong as what it needs to be. Or
Exactly,
whatever.
right? And particularly if you're putting 3 of them down.
Right.
For
Okay.
example.
But still, I mean, if it's let's say 6,000 pounds, I mean, let's say 7,000 pounds, that's still not that heavy. If you look at American pickup trucks and electric pickup trucks, like those are all over 7,000 pounds.
Yeah, so it's light. That's that's part of the ability for us to kind of go in and go to the places we want to go. Now, there are buildings in LA. Hundreds of buildings that have helipads on the top that are not used, right? Once upon a time, they had to be built in,
right?
For fire regulation.
Well, not only that, I'm just thinking of downtown LA, hundreds of parking structures that are just 6, 7, 8-story parking structures.
Yeah.
There's nothing else.
And that's really where we want to go, right? If you fast forward 10, 15 years, that's where we want to be. You can get your app out, and we have partnership with Uber and with Delta. So you kind of get your phone out, you tap in the app, you're like, hey, where's the nearest vertiport or takeoff pad? We pull up an Uber, it pulls up at the curb, you drive 3 or 4 minutes down the street. You go up in an elevator, you jump on the aircraft, fly direct, straight line, 200 miles an hour to your destination, jump out the other end. You saved yourself an hour, maybe more.
Right.
Depending how
This is kind of you mentioned Uber. This is kind of an outgrowth of the Uber Chopper, right? Like when Uber first launched,
Uber Elevate
used to go went viral.
Yeah.
That was like the funniest thing is like I was in Manhattan one day, early days of Uber, and I opened the app, and it's like you can take a helicopter.
But that's exactly it, right? So we actually acquired Uber Elevate, which was the team within Uber that was working on that service. And what they were trying to do was prove out that there's demand for people to jump in a helicopter or any kind of vertical lift and complete their journey. And they did a very successful job of that. Uber at the time were also looking at investing in us. And so we basically did this kind of swap deal where we acquired the Uber Elevate team that came with amazing knowledge of data and travel and demand. And they invested in Joby as well, so Uber investors in the company, and we're partnered so that we're going to integrate into each other's apps. But there's a fundamental truth here, which is people get really excited. Never mind saving time. People get really excited about jumping in something that's going to take them in the air because I tell you what, it's really exciting.
Oh,
right.
I
they
love
get excited, but there's also, I mean, how do you overcome? Surely there are people who are skeptical or fearful of. I'm going to get into what? Like, this is not a plane. This is not a helicopter. Those are, for all the flaws that you outlined. I mean, they're accepted, at least. They're generally considered safe enough. This is fundamentally new technology. And then, I mean, Johnny and I are very familiar with all the skepticism around electric cars, electric vehicles. And then you're going to, what's going to happen if I run out of charge or I don't know, hit by lightning or there's an EMP or I don't know, who knows, right? Like how do you
probably don't want to be hit by lightning.
Right.
It's a glowing orb in the sky. I mean, you're right. In the UK, where I'm originally from, we call them laybys. When you're in your car and something goes wrong, you pull off to the side of the road. It's called a lay-by.
Yeah.
And so the phrase goes, there are no laybys in the skies. So, if something goes wrong with your aircraft, you have to be able to land and you have to know that you can do that safely. Now, that's one side of the argument. But the other side, which is hopefully very reassuring, is the FAA, the Federal Aviation Administration, are very involved in this, right?
Pretty good track record. As we know, there's not a lot of plane crash. Like I was just reading, it's been 10 years since there's been a plane crash in the U.S. that resulted in a death.
Yeah, and that's because the
commercial. Lots of little planes are going down.
Oh yeah, but the standards that apply to commercial aviation are so high, and so whether it's the redundancy that's built into the aircraft or the testing that's done to make sure the aircraft's capable of doing what it says, the amount of regulation and safety that's built in should give people over time reassurance that this is going to be a safe mode of transport. It shouldn't be any different from getting in other forms of commercial aviation today, which we do every day.
Let's talk about that for a second because, in an airplane, in most airplanes, if the engines fail, you have some ability to glide to hopefully some sort of safe landing. Helicopters in general, I think if you have a dual counter rotating rotor, which is like Russian helicopters, you can auto rotate and land theoretically, although I think the risks are much higher. Is there anything about the way the Joby aircraft, if you're like wondering what the hell we're talking about, Google it because it is very interesting looking. 6 rotors, and they tilt. If you know what a V-22 Osprey is, like it'll go up and then
I think what Ed's trying to ask here is that does that wing, can it glide on that wing that it has?
Can it glide, or is there anything about auto-rotating, like, because the arrangement of the rotors is all around sort of the perimeter of the aircraft. Does that have any sort of power loss advantage if you needed to glide or drop down?
Well, the most important thing is the redundancy that's built into the aircraft. So if one of the propeller sets fails, there are 5 more. If one of the battery fails, there are 3 more packs. Each of those rotors that you see has 2 motors inside it, so it's already redundant as well. So if something fails, it's not kind of, oh no, what do we do now?
It's not fatal initially, right off the bat.
You can just go ahead and land and you probably won't even notice. And as part of the testing that we do and that we've already done, we test what happens when you take a motor out. So we'll fly the aircraft, we drop one motor out, you see a kind of a tiny little wingtip, and then it resolves itself, and the computer automatically manages the power that's going through the other 5 sets of propellers, and so you don't notice. And then you take a second one out, and we've done that too. And you still don't notice, and you can still land. And if you're worried about what happens even after that, then there's a wing, and the aircraft's capable of using that wing to generate lift, and therefore has a glide slope that will get it down to the ground.
Okay, so it is possible.
So one motor fine, two motors fine.
Yeah.
After that, let's have a talk.
Designed not to happen, but it depends where in the aircraft you start losing it, because obviously you need to kind of maintain some level of balance.
Right.
Okay.
Interesting.
So. This is fascinating, and Johnny mentioned it. He name dropped Toyota. Toyota is a big backer of you guys. So you have some, I don't know how you would characterize it. It's a kind of a swap deal with Uber. You acquired Elevate. I'm on your Wikipedia page. So you have Delta Delta Airlines investment. Ted Ogawa of Toyota Motors North America joined your board. That was a recent announcement. Who else? Let's see, JetBlue, Intel, a bunch of
well, let's start with
groups.
one. What is Toyota? Why is Toyota? Why do they care about a flying helicopter airplane company? Taxi.
There's a lot of history here. Okay. I would start by saying there are actually a lot of auto companies involved in this sector right now. So if you kind of scout around, you'll find that all of them, give or take, have dabbled a little bit. And
can I guess, because they have a lot of expertise in manufacturing 6,000-pound objects?
Yeah, I think so. Yeah, at scale, at affordable prices, and I think they're all looking at what is the future of mobility and how do we stay relevant if and when cars become only one part of the solution. And
I'm making this up as I listen to you, but if I was going to look for a manufacturing partner, Toyota, they are, I think, without question, the best manufacturers on earth, especially because they can do it again and again and again, cheaply and also reliably. They really do have reliability as like one of their, mission statements.
And
what's
the one thing you want your aircraft to be?
Be reliable. Right.
So that's what really drove it.
Is that where the partnership came from?
For sure. Yeah.
Okay.
Our founder, CEO Joby, drove a Toyota truck and often tells the story of, this beat up, decades old Toyota truck that he drove around. And so when the conversation came up about Toyota potentially investing, I think we all think the same thing, which is those things last forever. They're built amazingly well. What can we learn from them? So, at Joby, we're trying to do a lot of things. Right. We're designing parts for an aircraft. We're building the aircraft. We intend to operate the aircraft too as an airline. And so wherever we can build in expertise from people who already have done some of this stuff, we try and do that. And so, they invested back first in 2017 through their venture arm based up in Silicon Valley. And then in 2019, we went out to go and see them in Japan. And that's really where the relationship with Toyota Motor Corp started, and they came on board. They invested in 2018, 2019, and they led our Series C round. Okay. And so they are our largest external shareholder.
Oh wow, okay. Wow.
Yeah, and they have an arm which is all about the future of mobility. So it makes a lot of sense. Now,
we have a show about that.
Yeah, right.
And you're on it. This is perfect.
And to underline it, because we know a lot about cars, but like Toyota's manufacturing practices are not only world renowned, but I mean they literally changed the automotive industry in the 80s. Like everybody just said, look what they're able to do. We have to learn how to do this because they were into robots way before like the Germans and the Americans were. And then I think still to this day they're constantly coming up with new types of factories. But they do, right? Toyota consults for other manufacturers. Like there's like the Toyota manufacturing.
Well, people study their production.
But I think they have like a consulting wing where they'll go and like, hey, if you want to, the most efficient way, we're going to empower the workers to shut. That was always a classic problem in Detroit. Was like, if there was a problem, whatever, the bad car will go through and then just get sold to the customer and they'll hate it. Whereas with Toyota, like a worker, if you saw a defect, they're able to like stop the whole line, which is
right. That's lean manufacturing. That's it,
right? The Toyota production system kind of built those philosophies and ideologies, and we've learned a lot from them. So that, they not only help us as suppliers, so they supply some key powertrain actuation components for us, bits that move, but they also help us design the manufacturing facility. So we launched production in kind of low rate production back in the middle of this year. We just rolled the first aircraft off our low rate production line. Toyota is super involved in helping us design that facility, make sure we've got it laid out in the most efficient way.
Yes,
building the tools.
To me, that gives me, how do I put this, some reassurance that they're being built the right way. Because yes, Toyotas are built very well. You guys are Joby is Santa Cruz based.
Yeah, so we're headquartered in Santa Cruz.
Okay, so Silicon Valley peripheral.
Kind of, yeah. There's a real mood change when you go over that hill.
Yes,
out of Silicon Valley into Santa Cruz.
Once you drop out down the 17 in San Jose, it's a different world.
That's exactly
and
right.
Vice versa, yeah.
We're down there, but the low rate manufacturing facility is actually in a small town called Marina, which is a stone's throw from Pebble Beach.
Okay, so near, I'm trying to think, like
Monterey.
Marina's near Monterey.
Yeah.
On that side of the mountain?
Yeah.
Wow, okay.
Yeah. I mean, you can almost see one from the other.
Wow. Okay. Yeah, never heard of Marina.
I would think so. It's a Marina, right? Hey, who makes the batteries?
So we haven't put a name behind who makes them. As you might appreciate, it's a relatively competitive topic still. But we're impressed with what we have. It's an automotive grade battery that we're using in the aircraft at the moment. We're generating 288 watt hours per kilogram at a pack level in our aircraft. So, we got some of the best minds out of companies like Tesla to come and try hundreds of different cells, test them on the bench, build them up in interesting ways. It's a pouch cell that we're using.
Okay. So it's like, I know you won't answer, but it's like Panasonic or Sony or one of them probably.
It's my poker face.
Yeah.
But it's nothing fancy chemistry. Lithium ion.
That's right.
Okay.
Yep.
Super interesting. So we have to, and I should have said this at the beginning because I'm fascinated by the story. The more I dug in on this, first of all, the idea for having you on came from me because I know a lot of OEMs. Hyundai has a EVTOL arm.
Air taxi.
Air taxi arm.
Air taxi.
Many others do. It is an investment in the future. Everyone's trying to sort of stake their claim on this because, despite my skepticism, it seems like the next big thing. But as I dug into Joby, I kept hitting. I was like, that sounds like that camera. I guess I had some Joby stuff from this. It's odd. And then I actually dug in and. Your founder, Joe Ben Bevert, how do you say it? Bevert. He founded GorillaPod. I have the original GorillaPod. In fact, I was trying to dig it up to have it on to show you guys. So Johnny's like, what are you talking about?
Yeah,
GorillaPod.
Totally. So's the audience. Get to it, Ed.
The GorillaPod, if I may be so disgusting, it looks like a weird, like kinky sex toy. It's like, it's a tripod that's made of a whole bunch of just interconnected orbs.
I have a GorillaPod. I have one.
Everyone's going in a drawer somewhere,
right? Okay.
Right.
Apparently, it's a camera mount that wraps around like
that's
this.
Right.
Yeah. Like
you can clamp it to like anything.
Yeah.
And it holds position. I didn't realize it was so successful that this guy can then go on and found an electric vehicle company, but apparently he can. So Joe Ben no longer owns GorillaPod. Is that
that's
he
right?
Sold it.
Yeah, so he founded the company. I mean, he's a inventor and engineer all round, right? So, I think when he was a kid, he knew that this was what he wanted to get to, but the technology wasn't there yet. And so he went off and did a whole bunch of other things. So we did the Joby Gorilla Pod, as you said, threw off great amounts of free cash that helped him go found other things and invest his time in it. He also lays claim to one of the first, if not the first, mountain bike with suspension as one of his the things that he focused on in time. And then during COVID, he actually founded a company, a medical robotics company that tested samples of COVID samples for something like 25% of the kids in the LA Unified School District. Just kind of on the side, in the middle of building this amazing air taxi, he's off kind of building a medical bio company that's doing a whole bunch of other stuff. But it's incredible to work with people who are capable of doing all these different things all at the same time. And, I think he was just biding his time until the tech was ready for the one big thing, which is the flying taxi.
Well, let me ask you this, because we've talked about how there's all these players involved, and Toyotas and Deltas and everybody. What is, and I know you don't know the actual answer, but what size in terms of dollars is this as a business? The whole industry.
Yeah.
Like let's say, you said 2025, so 2035, which is a good time to, I think, kind of project in the future. Like, how much money is there in this?
So we don't give, as a company, we don't give numbers because
but not you. I mean, as the industry. The industry.
So company, people like Morgan Stanley have written these big
they
old
know
deep
stuff,
things.
Maybe. Yeah. They think they do. Yeah.
They talk about trillions of dollars.
Trillions.
Eventually. Yeah.
Trillions, like not 1 trillion, like more than 1 trillion.
One and bits.
2 trillions.
But nobody really knows yet exactly what the size of the market is, but everyone sees the potential. And so if we can bring it at an affordable price and we can scale it, you should expect to see thousands and thousands of these aircraft. We're talking about building a scale production facility soon. And that facility due to come online in time to help us scale, but that's going to be capable of building hundreds of aircraft a year.
Will that be in Marina or that will be somewhere else?
TBC.
Okay.
Watch this space. But the idea is, if we're building hundreds and hundreds of aircraft a year, and there are other companies building hundreds and hundreds, and that scales and scales and scales, eventually, there's no reason why this can't be a global industry.
So how much? So in other words, I need to go to Long Beach. I'm in downtown LA.
Yeah.
How much?
So, great question.
I'm taking me and my wife and my one kid.
How much? Okay. All right. Well, they're going to have a great trip.
But how much?
So we would say we want it to be as affordable as possible. We started out with
but what does that mean?
Yeah. Well, so we started out with that as a philosophy. We think when the service when we start the service, it's likely to be a little bit more expensive and the price will come down. We talk about it in terms of kind of comparison to Uber right now. So we'd expect a journey of a similar length to be equivalent when we start to like an Uber Black.
Okay.
So you're talking anywhere from $5, $6, $7 per passenger mile, and we're going to be charging per passenger. But we want to bring that price down over time. We want to get it down to more like the $2, $3, $4 per passenger mile. So it's not the cheapest thing in the world, but then neither's Uber actually, and we've all become very accustomed to using that. And so it depends a lot on the distance. But if you imagine, I don't know how far is that journey in a straight line?
Well, in a straight line, 15 miles.
Okay, so 15 miles. The expensive end, if you say it's like $7 per passenger mile, there are 3 of you. It's going to get
so $300.
Yeah, maybe to the high 200s.
Okay.
Yeah. So it's
pricey for now.
For now, but the idea is that price comes down over time as we scale, and then it becomes surprisingly affordable.
And it's worth mentioning, it would be crazy fast. It would be way faster than driving.
Well, that I was going to say,
like minutes, right?
So we talk a lot about this, but if you can give people time back, that's where that's valuable.
Yeah.
Let me hang on 1 second on that question. So Johnny and his wife and his kid go flying. What can they bring with them? Can they bring a suitcase?
So we're talking about 1,000 pounds of payload across 5 seats. So that's 200 pounds per person. But obviously,
what if you're big like me?
I don't know. Like you're over 200 pounds.
I'm about 250 these days. Yeah.
The average passenger's not, and so we're expecting people to be able to bring a bag with them as well. So it's like hand baggage basically. We're not expecting you to pack 3 suitcases for your vacation to Hawaii with you.
Like a standard rollerboard.
Yeah. So an average person plus a standard rollerboard is basically what you get. And, let's say not every flight's going to be full. So that's a max capacity. So if you imagine you're taking an aircraft that's got 2 people on it, actually you have way more space if you need it.
All right, I just want to see something real quick.
Oh, yeah.
Ed, vamp for me, quick, hurry up.
Well, I just want to go back and just talk a little bit about Joe Ben because Johnny moved off it. I'm very curious because I was a mountain bike nerd growing up.
Okay.
Hang on, real quick.
What was the full suspension mountain bike that he developed?
So I think he was doing it himself in a laboratory. So we'll dig it out. It's hanging on a wall in Stanford somewhere, I think, where he studied.
Okay. So hey, real quick, Ed, real quick. So I just Googled, Google mapped downtown LA to Long Beach. So put actual hard numbers behind it. So it's right now, and right now is about 11 in the morning. So it's not peak traffic, but it's 24 miles.
Mm-hmm.
It doesn't
by
seem
car?
right. Yeah, 30 minutes, 35 minutes. If you take the subway, it's 1 hour and 11 minutes. So if you can go 200 miles an hour for the most of the trip, that's 24 miles. Yeah, that would be a very quick flight.
Yeah.
And I just Googled it. Uber, it says an Uber to Long Beach from LA would take 30 to 45 minutes and it costs between $50 and $80.
Yeah.
Okay, so it is more expensive, but again, you get a lot of time back. And if you have a small
it's more expensive.
child,
It's more expensive because one thing that the Uber car ride doesn't do is they don't charge you per occupant.
Well, that's
if
right.
they charge you per occupant, it would be kind of
but the other thing too is Uber will come to your house where the Joby plane will not, so you have to then
for now
go somewhere. For now, yeah, no,
we're gonna get close. That's the problem.
Okay, sorry. Back to mountain bikes.
Okay, so the sort of the overarching question is, the founder again made his money on basically camera gear, camera accessories, but fundamentally, like he's a plane guy, aviation guy, or is he more like an entrepreneur inventor? Like does he fly? does Joe Ben fly like for fun?
I don't think he really does, but it's because he doesn't have time. I think he probably would if he could, but he's pretty busy running the company. I would say he's an engineer through and through. There are some people that just want to solve problems, whatever they are.
Okay. Interesting.
Now, let me ask you this. We said, 5 people counting the pilot.
Yeah.
Let's say I have more kids than that.
Yeah.
Or 2 families want to go somewhere. Are you working on Joby XL?
Yeah. So that the future. So this is what makes the sector really interesting for me is what this unlocks. So we can sit and talk about some of the initial near-term challenges of what this might not do, but it's like the conversation around the first Tesla Roadster. You're like, okay, cool. What good is this sports car that only has a range of whatever it was
100 miles,
right?
if that.
Yeah. But what it led to was everything that came and that we're now experiencing today. And so this unlocks our ability to either, first to accept the idea of aerial ride sharing and like living and moving differently using electric aircraft, but the batteries are going to keep improving, and if the batteries keep improving, we can either add payload by making it bigger, or we can add range and go further.
Right.
And we're a little bit limited. The one limiting factor here is the aircraft's small, like an SUV, and so it doesn't have a bathroom. So you're kind of limited on the amount of time that you can spend in the air.
Because you can just land anywhere. If someone really has to go, right, you can go down quickly.
But it also unlocks like other forms of propulsion. So there are plenty of conversations at the moment about hydrogen. So either hydrogen electric systems or pure hydrogen systems that will allow us to unlock something really special. So if we
big range,
you could it's not unreasonable to think that in X number of years we'd be able to travel 500, 1,000, 1,500 miles, maybe even further using hydrogen.
Yeah, you better get a bathroom.
Yeah,
which is gross in a small vehicle. And I've been in small planes with bathrooms; they're also gross.
Yeah, but we'll get to that eventually. But there are plenty of smart people in the sector thinking about how do we decarbonize all air travel, because it's a huge problem for the world right now.
Yeah.
The emissions from flight are significant contributors. And,
it's up there with cars. Yeah, it's not quite as bad as passenger vehicles, but it's bad.
Yeah. And so this is the unlock, right? This is the first iteration. We want to be there. We want to be kind of proving the point, but we want to take it much, much further.
And I'm sure you're paying attention. Like France, I believe, has just recently banned flights within France under a certain distance. So they're just saying, like, if you're flying from Paris to Lyon, I'm making this up, figure out another way to go. Don't take an airplane because of the CO2. Yeah. So Paris to Lyon is probably, Ed, you could Google, but it's probably like 300 miles.
I'd say so, yeah.
It's a nice train ride. It's a long drive, or it could be a quick
Sure could.
Air taxi.
Sure could, yeah.
Yeah, it could be, yeah.
And of course, that's in a country where they have an amazing rail system too. Right?
They have an amazing rail system, but also they're decarbonized. I mean, their power comes, I believe they're like almost 100% atomic energy. So they're very serious. Paris Climate Accords, obviously, they're serious about this.
Yeah.
Which the rest of the world should be and could be.
Yep.
I've been thinking.
Let me ask, because we were talking a little bit about the in-flight experience, which I'm very curious about. So just in the Joby aircraft, 4 passengers, 1 pilot. But is there a co-pilot seat? Are there 6 seats in it, or is it
it's
just
just
one?
5. So it's
just 5.
a kind of 1-2-2 configuration.
And if the pilot has a heart attack.
Well, he's going to need to land the aircraft pretty quickly, or she.
So do you have a way to autonomously take control?
Well, we're going to get there. I was going to get there.
Yeah, not today. We think there's a future where that's possible.
So you want healthy pilots, okay?
Yeah, but equally, we're not going to be particularly far in the air. We're gonna, as you fly along, there will always be identified emergency landing spots that you'll need to have as potential diversions, and so we'll get the aircraft down pretty quickly. So,
and also, I mean, helicopter travel today, there's not a co-pilot. Right. If you're on a commercial helicopter, there's a single pilot.
That's true. Yep.
And then, so that which leads me to the other question: what is? I mean, I don't know anything about. I know a little bit about flying.
Yeah.
What are the regulations for the pilot? Are they trained as a helicopter pilot or an airplane pilot, or what is?
Well, that's a really good question. It's actually something that's being debated at the moment with the FAA is how we qualify these pilots.
Sure.
Should they be helicopter pilots
big question.
or pilot pilots?
Right,
with fixed wing, and so it's likely to be some kind of hybrid mix of the two. But there are two things, I guess, that are important to say. The first is they're going to be fully qualified. They're going to be qualified by the FAA, and so they'll be safe, whatever they're doing. But the interesting thing here is that actually, compared to aircraft that were designed 15, 20 years ago, there's a huge amount more compute power within the aircraft that allows it to support what the pilot is doing. And so, on a normal, let's say, the aircraft that I flew to LA on today has a couple of little thrust levers, and so when you want to go fast, you push the thrust lever forward or you pull it back. We have 6 propulsion methods, and there aren't 6 little levers. The computer's doing everything. It's balancing the power. It's deciding how to tilt the rotors, and so the pilot is really focused on flying the aircraft, and so we're taking a lot of the option for human error out of the system.
And if anyone's spending time around drones, it's pretty common to have 4 rotor drones, but it's one joystick that's moving it. You don't worry about which motor's doing what and how it turns. It's the computer's figuring that out using GPS and all that.
Whereas in a helicopter, they're sitting there with both of their hands and both of their feet, kind of playing a church organ at the same time.
That's my favorite thing is to watch a helicopter pilot where they're so gentle on the little, whatever it's called, the stick thing that goes up and down. It's so cool.
Well, to that point, but
they're artists. I mean, helicopter pilots are amazing.
Yeah.
What are the controls the Joby pilots use? Is it a yoke like a plane, or is it a stick?
So we have 2 inceptors, which are basically joysticks. And so you have 2 of them, one in each hand. One basically controls the pitch and yaw and roll, and one controls the propulsion. So kind of making you either go up and down or forwards and fast and slow. Very, very simple. I've sat, we have a great kind of full surround, I was going to say surround sound simulator at our facility in Marina. And if anyone ever wants to come stop by and have a go, we'd
love that.
Guests.
In fact, Scott Evans is working on something. About
Okay.
All the EV startups in California.
Yeah, well, you're very welcome. But I can sit there. I had 5 minutes tuition. I can fly it, and I'm not a qualified pilot.
Right.
It's very, very simple to fly.
No foot pedals.
No foot pedals. All balanced through the rotors. We're all balanced through the computer system.
Now, is that 2-stick? Is that something Joby pioneered, or is this sort of like the standard for eVTOLs?
This is something that we've designed and developed ourselves. So the really important part of what we're doing at Joby is kind of a little bit from the Tesla mold is, when Joby came along, 2009 started the company, none of the technology existed. There weren't electric motors that did the level of torque that we needed. We're putting as much torque through our motors as a F-350 truck is generating, but we're doing that without gearboxes.
1,200 horsepower.
Right.
You sure about that?
1,200 pound-feet of torque.
Yeah.
1,200 pound-feet of torque by 6?
It would no.
Oh,
with all six.
Together. Okay, I was gonna say, that's very torquey, but it's possible.
We're doing that with motors that we design in house, and the battery packs. We built the battery packs and designed them in house. The control systems, we built them and designed this house because no one's ever done it before. And so so much of what we've done is kind of from the ground up because it just didn't exist. And so, the inceptors, the control system, it's likely that most of the people in the sector will end up going to something similar, but, we made that system.
Right.
Okay.
Right. And
so you mentioned, and this is, you keep mentioning roughly 2008, 2009 as the start of the company.
Yep.
There was a vehicle that my understanding is sort of launched everything called is it the Puffin?
Puffin.
The Puffin from
NASA Puffin. You know about this?
Yeah, a little bit. Yeah. So I mean, NASA naturally, NASA and the Department of Defense to some extent have been at the forefront of electric propulsion technology. Their idea was always to bring. They want to bring novel technology forward, and they want the U.S. to kind of lead the way.
How do we silently kill people?
Well, there's always a little element of a defense-related aspect to it.
I'm just saying.
Yeah, and we worked on
these attack helicopters are so noisy.
Well, we worked on an aircraft called the X-57, which is a NASA aircraft that was designed to kind of check.
And the X-57, if I have this right, was like a Cessna-looking thing.
Yeah, kind of. Yeah,
where the wing was removed. Yep. Your wing was put on, and it had, instead of like 2 props, it had a bunch of props.
Yeah,
like 18
exactly.
Or so.
Yeah, right. And that was all about investigating, in the very early days, what distributed electric propulsion would be like. Because, what happens when you take your 2 and you make it, let's say, 18, and you spread it across a wing, what effect does that have? And we actually had this, huge big rig truck.
Yes.
Based in California. We still have it in one of our sheds.
We'd like to drive it. But
yeah,
yes, I saw a picture of this thing, and I'm very excited.
It's amazing. We drove it along, however fast we went, along on a dry flat test bed.
What was it's called? The Joby. It has a name.
We call it the truck bird.
Okay, the truck. If you Google Joby truck bird, it's one of the. I saw it. I'm like, I love it. It's so Mad Max.
Yeah, right. But that's how in the very early days of a startup, there's the sort of compromises you have to make, and there's no reason why not.
And that was basically the X-57 wing.
Yeah, just on a truck.
It was a wing that would push a truck along the ground, basically.
Yeah, you drive the truck along and see what happens.
Okay.
See what happens with the wing.
Okay.
We weighted it down to large water tanks on either side to make sure it doesn't actually take off. But we built one of those. We have a bunch of other interesting test rigs actually up in one of our sites in California. We're in a quarry site, and we built this amazing. It's like a roller coaster. It's like a large circle.
Okay.
It's going to be like 1,000, 1,500 feet diameter across this circle. We have a tall pylon on it. We call it the whirly bird. And basically it spins around. It spins around like 50, 60, 70 knots. And it goes around day and night testing this large propeller scheme. But there are many ways you can test stuff that's not sticking on an airplane. And actually, the more you can do that, the safer it is. Because when you stop, things can go wrong when you put stuff in the air.
Yeah. So exactly. When your testing goes wrong, it just crashes. Whereas this, it's on a track.
It's already on the ground. You're okay.
Yeah. Oh, very cool.
So, sorry, we only touched briefly on this Puffin.
Yeah.
Did Joben see this and become inspired by it? And this was, and again, I keep
Ed, I think your timeline's a little whacked out because I think Joby was 2009. The Puffin was 2011, I believe.
No, it was. I have it.
I'll let you check on the date.
Yeah, I'm gonna say it's 2011.
It came out,
but people got excited about the Puffin.
Yeah, absolutely.
And just to describe it, if you're in your car and you can't Google, it was like a one-man pod which had 2 rotors, kind of like arms. Then it had like 4 feet, and it would take off up, and then it would kind of. It was like the Iron Man suit, but you're trapped inside.
And there's a bunch of those still out there. There's a company out there called Hexa who are delivering an aircraft, and they, same kind of thing. It's a one-person vehicle. The problem is typically very, very limited capability to do very much with a one-seat.
So it's like a quiet jetpack.
Yeah,
in a way,
your problem is you have to be able to pilot it yourself, and most people, they want to go to work and they want to get there early. Well, we probably said that about cars once upon a time, but you probably don't want to pilot yourself. But then that's what the Jetsons did. So
right. Well, I think we're starting to see this, and we're going to see it more and more in the future with as cars become more and more autonomous, where again you're giving people their time back.
Yep.
And, I think once you trust the technology, you just kind of trust it and stop thinking about it. So, like, yeah, if I could have something drive me to work, like that wouldn't be the worst thing in the world.
Yeah, right.
More importantly, if I've often said this about autonomous. When people are like, I need to drive myself at all times, I'm like, imagine you could go out to a meal and you could drink a lot of wine, and you could get home safely.
Yeah.
In your own car. You're like, that's the power of autonomy. And
Yeah.
like, oh, I do like to drink wine when I eat.
Yeah. The theory that I really like to come back to is something called Marchetti's constant. And so
Marchetti's constant?
Marchetti's constant.
Marchetti.
Yeah, you can Google it. It might be Marchetti. I say Marchetti.
Okay.
But if you Google it, basically is this theory. This guy came up with it a very long time ago, and he said people don't want to spend more than about half an hour. I think it is. Maybe it's an hour. I think it's half an hour traveling every day to work or their place of work or wherever it is they go every day. And so, human society, the cities we live in, basically are designed according to that principle. So, when we
designed on purpose or on accident?
Oh, kind of by definition, I guess. So, like, if you can walk and that's your only form of propulsion, everything's super close together. Right. And then when you get a horse and cart, those towns can get a little bit bigger. And then, what the car did was it allowed us to basically invent suburbia, right? Because you could live 20 miles from where you work or 40 miles from where you work, and you could still get to work in that time, that kind of golden half an hour, whatever it was, that allowed you to do that. And so, the advent of the car allowed us to do that. And so the question I always have is like, what will this technology allow us to do? If you can travel 100 miles in that same period of time, actually, I could live so much further away, and I wouldn't need to live within really dense, expensive community in Silicon Valley. I could live out by a lake.
But you guys must have had conversations during COVID where, like, Ed, who is not with us right now, can just as effectively
I'm trying to plug in my laptop.
He can zoom in, where you're like, wait a second, we're inventing this technology to take people to work. You don't actually have to go to work.
Well, that's true.
Right,
but then,
I'm sure you were having these conversations.
Yeah, but then actually, maybe the flip side here is people do want to go to work once or twice a week.
Yes.
And so if your journey is 30 minutes by air, maybe actually you can afford and or want to do that once or twice a week.
Right.
So you could live up in Tahoe and transfer yourself down to San Francisco, and you could have a totally different quality of life.
Right. No. And look, I've been thinking a lot about this very recently. I started riding around on an e-bike.
Yeah.
And I've it's one of those things I've known. There's this guy, James Kunstler, wrote this book, The Geography of Nowhere, which is about land rendered useless by the automobile.
Yeah.
I have friends that are bicycle enthusiasts that are like, we have to tear up the cities and start over. But, like, I think we've designed our cities wrong. Especially out west, where the car kind of led to the design of the city. I think we've done a bad thing, and I think, like, if air taxis do become not ubiquitous but like more commonplace, we could look at how we've designed cities. The problem with redesigning a city is it costs like trillions of dollars. But, like, I really think I don't know, Ed, how you feel about this, but, like.
No, it's true, and this is the whole thing about every mobility startup that comes along. Remember when the Segway was announced like 20 years ago? It was like, well, this is going to revolutionize everything. Everybody could, we get out of, LA. It's very common to see the freeways jammed up, and it's one person in a giant vehicle occupying.
The cars have
5
gotten
lane.
bigger.
Yeah, like an 8-lane highway. If you got rid of all of that, then if it becomes a smaller. This also was Larry Burns, his idea when he had this. They took the Segway, made it a little bit bigger, put a big EV battery on it, and then you could drive around. But yeah, I think going vertical makes a lot of sense with air taxis, but also as Elon has gone the other way, let's dig tunnels, right? Like let's go underground and avoid this whole thing. Let the cars roam the surface.
That's an idea that really hasn't.
I went through the tunnel in Vegas the other day. I was at CES when it was really fun. The problem is it just costs so much to dig underground, right? We don't need the great thing about what we're talking about is there's no infrastructure. So if a highway costs millions of dollars per mile, if a railroad costs millions of dollars per mile, sometimes like $300 million per mile.
Railway's insane. Railways doesn't make no sense.
We don't need anything in between, right? You build however much it costs to build a landing pad, pretty cheap. It's that grade,
pretty
right?
Cheap, yeah.
Then you need nothing in between. That's really the magic. You just fly through the sky.
Right. No,
But
that's a great point.
let's talk a little bit about that, because there are clearly, though, some obstacles for mass adoption, right? Cost has to come down. You have to get over you need to identify that there's actually a consumer desire and then market to that.
Yep.
But are there any specific regulatory hurdles, environmental, noise, whatever that you need
what's holding you back?
to get beyond?
Well, I think there's a very good question around public acceptance. So we're going to have to do a lot of work to make sure that people understand the value and the safety that's involved in flying these. Because I know, my litmus test is always my own mother. I'm like, hey, hey, mum, if I want to build this thing next to your house, what do you say? And she'd say, it's not safe. I don't want to see it. It's going to get in the way. And so we've got a lot to do for the average Joe, average Jill, to make sure that we've explained what it's about. But the conversation often then tends to, how do you control the skies? How do you make sure there are no traffic lights, right? There are no stop signs. How do you control it? Now, the FAA has very good regulation in place that allows us to fly within the skies, and actually, a vast proportion of the sky is not really controlled. It's really only around the major airports where there are very strict regulation. You can typically just fly your aircraft where you want to.
And if I can give an example, I had a friend in town from Florida who's just got his pilot's license. And he's like, I'm thinking about flying to Catalina, which, beautiful little island. And he thought about it more, and he's like, LA is really crowded in the air, and I'm like, it is? And he's like, oh, yeah, compared to where he is in Florida. There could be 50 small aircraft up at any one time. And I'm like, that's crowded? But apparently for a pilot, that's crowded.
Yeah. Well, when you're moving at 200 miles an hour and you're not necessarily moving in through obvious lanes, that can be the case. So, we're going to add aircraft into the sky. And today, we could do that today and it would be fine and we'd be able to move around. But as and when we scale and, more aircraft come online, then we may need to think about things a little bit differently. But the FAA already working on that. So they're actually using the LA Olympics in 2028 as a kind of test case, or I guess base, to make sure that they are capable of having all the right systems and regulation in place to control high volume aircraft movements through the air. And it's not rocket science.
It's close.
Now, do you
aircraft science?
Right.
Do these aircraft operate at any kind of? Is there a different flight ceiling or
what area
are you
working at?
So the aircraft doesn't have a pressurized cabin, so you're breathing the oxygen that's around you, which means that you have a natural limit of kind of something just north of 10,000 feet.
Oh, you would get that high?
Yeah, well, actually, probably not on general, but that's about as high as you want to go.
And just to stop you, because I think I've been on a bunch of helicopters.
Yeah.
Usually you're about 1,000 feet off the ground.
Yeah.
300 meters, something like that.
And that's kind of where we expect to be. It's probably somewhere up to about the 3,000 foot mark is going to be where average operations take place. Lots of factors figure into that, like the other air traffic, the route that you're taking, the buildings.
You want to be above
obstacles.
Helicopters,
Well, you want to be above whatever is below you.
Right.
But yeah, there are a few different factors.
So
but
that's higher than I
digits.
was imagining, actually.
Well, it depends on the route, but to some extent, it doesn't matter because actually, if you're on the ground and the aircraft's 1,000 feet above you, you don't hear it anyway. So.
Right.
So wait, just so I'm ignorant, where helicopters operate at what? Like, are you operating in the same airspace as a helicopter and a non-pressurized private plane?
Yeah, pretty much. Yep. Yeah, and then, there's a wide variety.
But helicopters rarely go over 1,000 feet. I mean, I mean, once in a while, just my own experience of commuting in them. Don't ask.
Sounds like a great job, though.
I mean, that's another episode. But I think about 1,000 feet, something like that, is the ceiling I've seen.
Okay.
And then try to think. I've flown a couple like Pipers and Cessnas. Took a few pilot lessons. And they're like not that high. Compared to a commercial plane is above 30,000 feet.
Oh, that's sure. Yeah. So when they're
pressurized,
up there.
Yeah. Okay, so 2,000 to 3,000 feet, somewhere in that.
Yeah. It depends how far you're going. If you've not got much time to get up and go back down again.
That's true.
So
if
it's a 5-minute hop, you're probably never getting that high.
And that's a good question though. So you says the range is right now 100 miles or so.
Yeah.
What like to make it financially make any sense? Like, is there a minimum distance?
Well, probably not. It depends a lot on the geographical barriers, I think. So, back to the JFK to Manhattan example, you've got to go around water. And so, the actual straight line distance is really not very far at all.
Yeah.
But if you're on
And
the
the
ground,
traffic is
it's
wild.
it's a really long journey. And so, that I think that's like single-digit miles, that journey. And so,
definitely. Yeah.
And so that's going to be viable for sure.
Or the other one, remember Newark and LaGuardia. I've actually taken a helicopter from LaGuardia to JFK, which is 4 or 5 miles, if that. But and it was a quick helicopter flight. By car, that would be just 90 minutes minimum. So.
Yeah, well, that's exactly it. So,
Right.
we think there's a great demand for that. Actually, we, even though we have a range of 100 miles, we actually expect the average journey to be more like 25 miles based on the demand that we've seen and looked at.
Downtown to Long Beach, apparently 24.5 miles.
Perfect example. And we know that, from the data that we looked at, 99% of all journeys in New York and LA today are less than 50 miles. Yeah. 99% of all the journeys.
99%, which is huge. Yeah.
Yeah.
And we talk about this all the time. That's such. I'm so glad you said that because you should buy an EV or think about an EV. No, because the one time a year I do a road trip, it's like, but most of the time you're driving nowhere.
Yeah. Exactly.
An EV is perfect. It's everything you actually want. So that's a good stat to know of.
Yeah.
Johnny kind of asked a little bit about it when we talked about the pilot, what happens if he has a heart attack and the autopilot, that kind of stuff. What EV? We talked, Johnny and I, this whole podcast is about the future of mobility. We spent a lot of time on EVs. This is one of them. But we also spent some time talking about autonomous. You were quick to kind of shut down autonomous, but this seems kind of ripe for it, right? If you're just talking about sort of commuter like lanes or going between an airport, again, kind of two fixed points. Like, why wouldn't you? Why don't increase the profitability and turn add another 20%?
If I can jump in before you answer, and we know Uber really wants to get rid of its drivers. So,
autonomy is definitely on the radar, I would say. There's no practical reason why it wouldn't happen. And actually, we're working on the technology now that would allow that to be the case. There are probably two things that stand in our way. And the first is public acceptance. So back to the point of how do you persuade your friend, your mother, your child to get on get on a vertical aircraft that's electric powered with a pilot, then having that conversation without the pilot is going to be next level. So that's one, there's public acceptance. And then two is the FAA and the regulation just doesn't exist yet to allow that to happen. So, we anticipate a future where absolutely that fifth seat becomes a passenger.
But that's huge. And I like that you keep coming back to the FAA because probably the best safety record there is,
Yep.
And so that's, and the other thing, just to go with that, when I'm in a helicopter, you can grab the pilot at any moment, and I have a lot of faith in their ability, because helicopter still makes no sense. Like, how is this thing happening? And in my experience, the pilots have all been kind of studs, and a lot of them are Air Force veterans, or RAF veterans. When in England, when I fly them, and so it's like, okay, this is I feel safe here. So
what about the what about the intermediate step though? Remotely operated pilots.
That probably is the intermediate step. I would start by actually saying we're kind of at the intermediate step because actually the aircraft is already doing so much for the pilot, and that's the bit that we forget. Even in today's version of the aircraft, the computer is taking care of an awful lot of stuff for the pilot. The pilot's focused on just flying. But then, the expected kind of development of this is remotely controlled, or one person sitting on the ground looking after a small number of aircraft, and that eventually grows and grows until they're monitoring, however many aircraft. And it's not so far away. And there are companies in our sector that are looking at today. There's a company called Whisk. You should look them up. They are focused purely on delivering autonomous aircraft. And they haven't put a time frame on when they expect to bring it into market, I think. But, for sure, it's a reality in this sector. It's just a question of when.
But how do you feel about it personally? How do you feel about it if the person flying the aircraft has no skin in the game?
Yeah, well, I mean, I'm personally a risk-taking tech evangelist, so I'll jump in anything.
Right.
I give my left arm to have a go in a Cruise robo-taxi. So
well, I was going to say though, I believe the strategy with Waymo and Cruise with the driverless taxis and vehicles now is an operator can take over if something if something malfunctions. There's a way for like a drone pilot essentially to take over.
Yeah, I mean, today when we do our flight tests, so we test our aircraft up in Marina. We fly pretty much every day at the moment, depending on the weather. It's often foggy in Marina, but we control the aircraft from the ground. We don't have a pilot in it because you can do this now. You can control the aircraft from the ground, has all the screens and all the radio connections, safer to do. So that's what we do. We will put a pilot in there, and we said we'll do that this year. But the technology exists for sure to let someone control it from the ground.
I think it goes back to what you said, the regulations. Like you just can't do it, which is fine by me. I'm a big believer in the FAA. I like regulations.
Yeah.
We saw what happened in the submarine industry without regulations.
Exactly.
Exactly. Regulate away. Yeah.
So you've been very forthcoming and mentioned a couple of your competitors, but who would you say is your like number one or two competitors in this space?
So there are a bunch of different companies, and they're all trying to do sort of the same thing. However, we've all designed aircraft that look very different and have different mission sets. So over in Europe, there's a company called Volocopter based in Germany. They're planning to do something, including flying at the Olympics next year in Paris. They have a 2-seat aircraft and eventually a 4-seat aircraft that has very short range, so kind of very much inside the city, but they're making great progress. There's a company called Lilium that I used to work at in Germany. Famously, Frank Stephenson, the auto designer,
we know Frank. You love Frank. Yeah.
helped design the aircraft. That's a completely different looking aircraft. It's got something like it was about 30 little motors, little mini electric jets across.
Frank, just to interrupt you, designed among many other things when the BMW relaunched Mini, the first Mini Cooper. That was Frank. He was
Maserati.
a BMW, Maserati, Ferrari.
MC12.
McLaren. He did the MP412C.
He told me a very funny story about the wing mirrors on the Mini that you should ask him about one day. I don't want to. It's not a family friendly story. So.
Well, I know that when they did the first Mini they showed for the auto show car, they were like, oh, there's not an exhaust tip because it didn't run, and he was drinking a Budweiser, and so he handed like the modelers. He said, here, just make it look like this. And they modeled a Budweiser can, and that was the tailpipe of the first Mini was identical to a 12-ounce can of beer. So that's Frank. He's awesome.
That's impressive.
He's a dude.
He also helped design a couple of the other aircraft in the sector. So he's been doing I think he did some work for a company called Archer that's also based in the US. They're just in Silicon Valley as well, making good strides. And then there's a company called Beta up in the northeast corner of the US. They're partnered up with Amazon, amongst other people. They're kind of focusing on electric aircraft that take off conventionally first rather than vertical, but they'll come back to vertical. So there's a whole bunch of companies trying to do roughly the same thing.
And the
You
reason
didn't mention Supernal.
Yeah, so Supernal tied up with Hyundai.
That's why I was wondering. Like, you guys have kind of a clear Toyota tie-up.
Ed's picking
Hyundai.
fights.
Yeah.
But what
I'm just curious.
They're a while away. So they've given their timeline as kind of 2028ish and beyond, I think. So we think a little bit more near term.
But you want the reason I think you're so forthcoming. Usually when there's PR people on, what? There's other car companies? Like no, but you want a rising tide, right?
That's exactly
you need
right.
This industry, you can't be the only one.
Yes,
you need. What is critical mass? Is it like 4 air taxi companies? I'm sure you talk about this.
Yeah,
but.
there are a couple of different reasons why it's important. I think we want investors to be interested in the sector.
Yeah.
We want the U.S. government to take creating the regulation seriously.
Right.
So we need them invested, and they are. Like we've never seen support like we have at the federal, state, local level recently because there are so many companies involved in supporting.
And why do you think that is? Because again, like our Congress. I don't know how it is. I know a little bit how it is in the UK, but our Congress. They're not only like very old people, but they're just way behind. They don't understand anything.
Well,
why would there be support?
There's a lot of enthusiasm. I think what they
Okay.
see is two things. One is the sector is actually coming to life. They're seeing aircraft that are flying in the air. They can come and see it, and it's not anymore this kind of crazy dream. It's really an aircraft that you can touch and see. And the second is, they want the US to lead the way. I think there is some sense that, particularly on the defense side, that the drone technology was better developed elsewhere in the world, and maybe some other countries stole a march on the US.
Okay.
And so we really want this to be a sector that's kind of owned.
I keep forgetting about the
China
military.
has one. Speaking of that, China has is it Xpeng or is it
EHang?
EHang.
EHang is the eVTOL company for China, and they are developing. There might be an Xpeng as well, but the EHang just recently kind of got some form of certification. But again, it's a 2-seat aircraft with a very short range, and I don't know how rigorous they are.
But there's look. That's the thing, right?
Yeah.
China's they're not the FAA. They don't have that, and also, but if you're developing technologies like. The Chinese government can clear all red tape out of the way overnight,
Yes.
so we better get a jump on it.
Yep.
Yeah. I keep forgetting about the military application. And I know you probably can't give any specifics, but how much of the business is focused on DoD stuff?
So we've been funded by the DoD.
Yeah.
They provided us relatively substantial support and funding. So, our early aircraft was tested at an Air Force facility. We're about to deliver, but by early next year, we'll be delivering our first aircraft to Edwards Air Force Base for them to trial and use. And so they have been very big proponents. There's a program called Agility Prime, and it's basically a dual purpose technology development scheme. So they are very interested in supporting stuff that's both commercial and has defense applications.
Right.
Certainly, to begin with, the conversation is about logistics. So,
Sure.
If you're moving water bottles or people across an Air Force
ammunition,
base, whatever. But if you do it with a Black Hawk, that's hella expensive
and noisy.
And if you do it with an electric aircraft, it can save you a whole bunch of time.
Very
Should be
quietly.
safe.
And it'll be a
Let's
whole bunch
get those
mortars to the front.
Something like that.
Okay,
So they've been very involved and very helpful. We recently had 4 Air Force pilots come and learn how to fly our aircraft. They flew the aircraft down in Marina. We had the Marines come through as well.
Sure.
We've had conversations about Coast Guard applications, Border Force, all sorts of things that we can do.
There's full. That's what the Air Force does, right? I mean, they take it to the air, and then
a step beyond that. What about private ownership? Is there a model where hey, I love this thing, looks awesome. I want one. I'd love it. I'd love a recreational aircraft.
Yeah, there are companies in the sector that want to deliver that. I don't know how realistic it is to begin with. Our business model predicated on operating the aircraft ourselves. We think that's the best way, the most efficient way, and potentially the most profitable way to run the business. It'll be a chunky old investment for somebody to A, become a commercial pilot, and B, then have this thing sitting somewhere. And, it's not as if it's going to sit in your garden on day one, or in your backyard. It's going to be something.
People own their own airplanes. The guy in our industry, Micah, works for a competitor, Kelley Blue Book, has his own helicopter that he flies around in.
Yeah. So, I think the other problem is our ability to scale production is going to be, it's going to be hard.
But so your business model is essentially the Uber model, right? So,
except we'll own the aircraft.
Yeah. Okay. Interesting.
How much would one of these aircraft?
Great question. We haven't put a price on it because we're not selling them, but it's going to be millions of dollars.
Tens of or single millions?
I don't know. No,
I mean, if a Honda Jet's $5 million, it's going to be less than a Honda Jet. But so Uber famously, they have independent contractors.
Yeah.
Are your pilots independent or do they work for Joby?
So the pilots that we have today that do all the test flying are all employees.
No. But once you're flying Long Beach,
it's gonna depend on a whole bunch of different things. How we're operating the aircraft. So in the US. Probably our own pilots, and we plan to train them. When you start looking overseas, and so we have partnerships with airline ANA in Japan. We're looking at South Korea. We've talked about operating in the UK before. Often when you go to other countries, foreign countries, they have ownership rules about who can own airlines.
Yeah,
sure. It might be that it's contracted through different companies, but here in the US, ours.
So. Sell us on Joby. You mentioned, and this was a little bit of a follow up to that me asking you about your competition. But I think you you mentioned, I think it was Verticopter and Lilium, and I kind of looked at them a little bit. And now I know why you mentioned yours. I think that you do have, and I'm not just being our guest, but it sounds like you're a little bit farther along and you have more of a commercial model with the number of passengers you're gonna launch with. But what puts you guys out there? Fund your next round. Just go ahead.
So we're actually publicly listed. We're on the New York Stock Exchange.
Yeah, you guys went with a SPAC.
Okay,
right?
pump up your share price.
Yeah. So I will public warning. This is not designed to bump up the share price because I can't do that. But I will tell you about Joby. The fundamental truth is we started earlier. So, because we were there in 2009, we weren't a company that's founded in 2014, 15, 18, 20. We've been doing it for longer. And it turns out building aircraft is hard. You have to do a lot of iteration. You have to build prototypes. You have to fly them, find out what's wrong and fix it. And, we stole a march on a lot of our competitors by being the first. We've flown full-scale prototypes since 2017. We've flown more than 30,000 miles with our latest version of our full-scale prototype. We've already launched production. We're furthest through the certification process with the FAA. We're the best funded company. I'd say we have the best experts in-house. We think we have a very, very solid business model that matches what we think is the demand for the market that makes most sense. We work hard. That's about as far as I go.
I mean, you left out the I don't know if it's partnering, but the Air Force stuff. To me is like that's. I was reading up on you. I was like, oh, really? We've a little bit. We've worked with the Air Force, and it's a pretty professional organization, obviously. To me, that had a real legitimizing effect. I was like, okay.
and Toyota, the Air Force, Delta. It's the world's leading airline.
I like Delta.
And then SK out in South Korea. All these people who have come along and invested in the company. We take those as votes of confidence, but there are also people that lend expertise to us. It's a really stellar set of partners that help us bring it together. Whilst I was on Toyota, I was I thought it was interesting. There's a little backstory here. So we recently appointed Agawa-san, who is the CEO of Toyota North America, to our Joby board. And so, he's there on our board, at our board meetings, helping us every day to make sure the company's moving in the right direction. But our relationship with Toyota goes back quite a lot further than that. The first conversations we were having were, with a guy called Akio Toyota, who
we know Akio.
Right. He's an amazing guy,
yes,
and
the chairman. Yes,
exactly. We actually just recently, I'll get this name right. We actually just recently had Sato come and visit, who's the new CEO of Toyota.
Yep,
he came through.
Sato.
Yeah, exactly. He came through just a week or two ago, actually, through our facility, and came famously the chief engineer of the the Lexus LC coupe. I think. And he was kind of like underneath the aircraft, fiddling around with bits and having a look at everything. And the depth they come in and the history they come with. But the thing with Akio Toyoda was, an enthusiasm for future mobility. And his great-grandfather, if I get this right, was the guy who founded the Toyota company, full stop.
That's
and
true.
That was before they got to cars even. They were working in looms, I think, and other
famously, fabrics.
And they have a carbon fiber loom. So maybe that's what's helping you guys build your
but this guy,
right?
Sato,
I know him.
Sato,
I went on the launch of the LC, and he's a nerd. I mean, he's an engineer.
Yeah.
Like he was going on about the top of the shock mount for like 20 minutes. I'm just like, what? Like, can we drive the car yet? Yeah.
Well, so back in this history. So the original guy, right, Sakichi Toyoda. So he was the guy that found it. Now I wrote this down because I was writing a blog about this the other day. He was born 1867. So not kind of a while back, but during his life, he came up with the idea, and he went to an organization. I wrote this down so I get this right. But the Imperial Institute of Invention and Innovation, or I guess the II, in Japan in 1925. He went to them in 1925, and he said, "I want to start a prize fund of 1 million yen to find a battery that stores more energy than gasoline, so that I can power an electric aircraft." And he said that in 1925. So all through the history of Toyota, I think there's been this desire to kind of get back to using electric powering aircraft and doing something that's really, I mean, that kind of blew my mind. That, you know, like basically 100 years ago.
Well, it
this
all,
idea
but I mean,
existed.
if you go back and look at old cars, like everything we have today was figured out back then.
Yeah.
Like
Yeah.
you know, I always say there was I think it was a Pierce Arrow 1910 that had turn by turn navigation. You had to go to the courthouse in Cleveland and put in a paper disc, and then that would get you to Cincinnati.
Yeah.
Based on the odometer, but it existed. It just didn't have computers to do it. So yeah. And you know, famously, you're drinking out of Jay Leno's coffee cup there, but we had him on, and he was explaining, you know, in 1906, a third of the cars in the U.S. were gas powered, a third were electric, and a third were steam. No one really knew which way it was going. So, you know, a battery for a flying contraption. Like, not shocked at all to hear that.
Yeah,
you know.
yeah.
Right.
Well, and that history, you know, the kind of aerospace meets automotive is a long story, right? I mean, I was at Rolls-Royce in the UK. I worked in the aerospace division, but you know, they famously in our you know, we had this, you know, a facility up in the north of England, but we had a little museum. In the little museum was the Silver Ghost, right? I mean, like, this was one of the first cars they ever made. It was sitting there that we could go see and, you know, show to our friends, and like, but the history of, I mean, I guess you all know that Rolls-Royce started as a car company, right? And the British government came to them and were like, "Hey, First World War, Second World War, you guys
we
are
need
real,
some engines."
you're like, you're real good at engines. How do you fancy aerospace?" And so, you know, basically everything that we're doing today is actually rooted in the automotive sector, right? Whether it's the batteries, the technology, the avionics, even, you know, a lot of that is derived from progress that's made in the auto sector.
Yeah.
Okay. So just as we start to close it up here just a little bit, I imagine a lot of our audience is listening or watching, they're like, oh, come on. Like, I'm still very skeptical on this, about this. Well,
speak for yourself. I'm like, when can I take
I know
this?
you are, but where are you in the journey, right? You guys are about, I think, 15 years in or so.
Yeah.
What's the next sort of waypoint? And then, because you're the head of marketing, communications, and brand, what's like the moment where you're going to land and everyone's going to, like, the whole, is there a Super Bowl commercial you have planned?
When does Taylor Swift arrive at one of her concerts?
Well,
in
Johnny,
a
I was going to say, like, when you guys were talking about stadiums, like, I think you have to be planning a moment where the quarterback of the Packers, right? He lands in front of the stadium.
I think you want
3 hours before game day. And
Jordan Love's probably fine, but yeah.
I use
what's the moment?
I use this is too far away, but the last LA Olympics, you know, famously the jetpack guy landed on the field, right? I'm like, what if, you know, 2028 we land our thing? But hopefully it's sooner than that. So there are a couple of things that are happening right now that I think are going to bring it to life for people. So we're going to put our first pilot in one of these aircraft and fly it around with a human on board this year. That's going to be one of those moments where people are like, okay, well, this seems pretty real. And then, you know, we have plans to go demonstrate the aircraft in cities, you know, around the world and show people what this looks like when you have it in a big city. And I think taking it out of a test environment, putting it in a real environment, people will suddenly start to twig this is real.
You mean like air shows?
Yeah.
Oh, okay, cool.
But also, you know, I think if we take one to Edwards Air Force Base, you know, by early next year, we'll be seeing it flying around in a real life. All these things kind of add up. But like, you know, the really big moment is when we start putting people on it that are not associated with our program. And we're going to have to do that before we get to launching commercial service. And we plan to do that in 2025. So, you know, the next kind of 24 months, at least from a marketing perspective, are going to go by real quick. And I think the bit that people don't get is we already have 15 years of history behind us. You know, the technology is basically there. The challenge now is production and certification. So, you know, at our production facility, the first one's already rolled off. The second one is you know, on its way. We're already making parts for the next one on the production line. We're going to announce our scale manufacturing facility soon. So this is going to come an awful lot quicker than most people expect.
Okay, so Johnny was trying to nail you to the wall on a couple of things. Yeah. When is your a New Yorker or a Los Angelino, as we call them?
Yeah. Or hey, I want to go from San Francisco to my job in San Jose.
No. When are we going to be able to pull up the Uber app, and be able to click on the Joby air taxi? Like, can you give us a year?
Well, so we plan to launch service in the US, and we said that we would launch service most likely in cities like New York and LA. and we would do that in partnership with Delta. So, we are talking now about where we're going to do that specifically, and we're talking about having aircraft ready to do that in 2025. So that's your day.
Let me ask you a question. This is a big one for people that travel a lot. I currently have 867,000 Delta Sky Miles. Yeah. Do I get Delta points? Do I get frequent flyer miles if I take a Joby? Yes or no right now?
This is a conversation we're having. We haven't decided yet, but I'm pretty confident.
This is big.
I'm pretty confident there's going to be something for you.
You might have an early adopter, eager early adopter.
Sounds like.
Hey, by the way, that
idea.
sounds like a lot, but it's. I just looked. I have like I had 260 on American that are about to expire because I don't fly them anymore.
Oh yeah,
and that's good for like one ticket to Japan.
Well, yeah. But so I mean, look, it's how it's I feel rich, Ed. I'm going to soon be a millionaire.
Don't take the man's dream away from him.
let me burst your bubble just a little bit.
No. I'm well aware. I was looking into. Yes, I was looking into.
Okay.
Our friend of ours just moved to Tokyo, and I said when I get to 1 million, I'm going to treat myself.
Sweet.
For most of those miles on a nice ticket.
We plan by the way to be flying aircraft in Japan as well. So the 2025 Osaka Expo, which is the World Expo, the next one after Dubai, they plan to have flying taxis there too.
And to reiterate that point, you were saying that the other markets besides the U.S. you're going to go into will be places where you can own the vehicles.
No, not necessarily. So foreign ownership rules about airlines dictate this, that 50% ownership has to be local, typically. So it may be that a different company, a leasing company, or another airline will own the aircraft.
But so you're planning on France?
We haven't really had particularly active conversations about France. So we've been looking at Japan, South Korea, the UK as kind of the most likely external markets.
Okay, but not Germany.
Well, so the
I'm just thinking of big first world population center places.
And there are lots of people that are looking at Germany. It's covered by an organization called EASA, which is the European version of the FAA.
Okay.
They have a slightly different take on the regulations, and it's another whole regulatory body. So the speed at which you can go through it. I mean, there's 100%. It's a great market, but we have to kind of put our effort behind one large regulatory body for now.
But why is it only like high density urban populations? Obviously, I know that like the business commuter, but what about like Hawaiian Islands?
Yeah,
like, wouldn't you like an island hopper?
100%. So
that would be
air tours.
Great.
Island hopping, particularly in places, I often talk about the Maldives and Hawaii.
You're so European. I mean, English. Go ahead.
The Maldives.
No. Just we Americans never think of that. We just think of Hawaii and the Caribbean.
Okay.
But the Caribbean?
Yeah, and basically these places are all also affected by climate change, and rapidly so. And so I think there's a particular bent to go there and argue that we're going to bring in something that's better for your environment as well. So there are so many use cases.
But also,
when you think about
helicopter tours of Hawaii is a model, but again, they're really loud, and you have people like just want to sleep on the beach.
Yeah, and protect the wildlife as well, right?
Yeah,
so there's a million reasons why it makes sense. And if all you need is a landing pad at each end, then you can have what are called very thin routes. You don't need, imagine if you could go to the developing world and do a flying doctor thing, right?
Yeah.
And you could just have one aircraft that passes between these various ports, and it would still be valuable and worthwhile doing because you're not building a huge amount of infrastructure. It's not like you have to build a 4-lane highway.
No, but you do. We haven't talked about this, but you do have to put like charging infrastructure in.
Yes. Let's talk about that. Talk about that. How so? Currently your maximum range, you're talking about 100 miles.
Yeah.
From takeoff to landing, the vehicle lands, how much range can you get back and go can you go back, or do you have to charge it?
Yeah.
100 miles? And then how long does it take to charge, and is it like a standard, like the EV chargers that we have, the CCS charger?
So we're planning on the electricity draw to be similar to a Tesla supercharger. It's gonna be a similar sort of infrastructure that's required for a supercharger. The handles themselves still working through the sector in terms of like how the technology is exactly going to work, and people have different ideas of what that should be, much like they did in the auto sector. But the idea is that we were able to rapidly charge. So our kind of MO is that we want to be able to recharge the aircraft on the vast majority of trips in the amount of time it takes to offload the people and then reload people.
Oh,
so
that's fast.
if you've gone, if most journeys are less than 25 miles,
right,
the amount of battery you've used is actually really not all that much.
Right.
And so, it's a 7-minute journey. You'd land, we offload the people, we do it really quickly. A few people snap a few selfies, they jump on the aircraft. We will have recharged the aircraft within that period of time.
I'm assuming then with at least an 800-volt architecture?
Yeah, so we haven't put any details on numbers out yet.
But higher than 400, could you say that?
Yeah.
Okay.
So we're working, it's big.
Because we see that, like, our SUV of the year was the Hyundai Ioniq 5 is an SUV. That's another show, another argument. However, because it's an 800-volt electrical architecture, we can go from 10% to 80% charged in about, 18 minutes, something like that, pretty rapidly on a 350 kilowatt charger.
Yep.
So I assume you're looking at something along those lines.
Yeah. And the critical thing is about keeping, to keep the price down, we need to keep the aircraft in the air. And so you want to be able to turn it around as soon as you possibly can. So you want to minimize ground time.
Right. And there's probably some like minimum charge state before it can take off.
Oh, yeah. So
you want to have
what we call reserves, basically.
Reserve,
when there's a minimum, it's actually measured in time rather than percentage of battery.
Sure.
But you have a minimum flight time that you have to be able to achieve if and when something would go wrong. If you're landing here and they're like, oh, can't land there because there's a protest.
We're at
then we need to be able to go to wherever the next place is. And so the FAA again will regulate exactly how that operates.
I'm looking at pictures of this thing online, and I encourage you, if you're listening and you're not driving, to pull it up. So how do the doors open? Is it sliding doors? Are they pop open?
They open like car doors, actually. So there are two sets of doors on either side, hinged at the front. You open them and then you jump on in.
Okay, and then you you haven't flown on one, correct?
No, we plan to put our first pilot on board this year. So I've sat in it and I've sat in the simulator, but I've never, not yet, taken off.
So if I can be a skeptic for a second here. So you're like, okay, we've been doing this for 14 years, 15 years. We're going to be doing this by 2025, but it is late August of 23, and no one, hasn't even been a pilot on board yet. Like, is your time frame a little optimistic, maybe?
So this is putting someone on board is the last thing you do, and technology allows you to do that. So we have a pilot who sits on the ground and pilots the aircraft. He or she is basically on board the aircraft, except they're not. Right? Everything about it is the same.
That's what I'm getting at.
Yeah.
Like, so
everything is the same. We develop the technology, we'll certify the technology, you put somebody on board. I mean, it's a
wait a second. I thought you both had misspoke. So you guys have flown these things, but
without a pilot
remotely.
On board. There's a guy, like a drone
including when the military came, and so they trained on your
simulator.
The simulator,
but they flew the real aircraft, but they flew it from the ground. So they have all the same controls, they have the same screens, but they're not actually physically in the aircraft.
So what's so what you're saying is the process for developing an aircraft is the last thing you do is put a pilot in.
These days, I mean, it's certainly not been the case in the past.
Sure,
technology allows you to do that now, and if you could,
Chuck Yeager would tell you different.
Yeah, but if you could, why wouldn't you wait until the last possible minute? Because things do go wrong with test flying.
Right. Okay, that's fair.
Yeah.
That's fair. I'll buy that.
Yeah. Well, how many parachutes is he going to be carrying? Actually, that's a question. Is there's no some of these. I mean, I don't want I hope I'm not insulting, but this is somewhat experimental at this stage.
Yeah.
Some of them have on board like a chute.
Yep.
Like
there's a Cirrus aircraft that has a parachute on it.
Right. Does this have anything like that?
No.
That it's a vertical? No.
And there's a good reason. It's a really interesting debate. And basically, you take a relatively high weight penalty for having a parachute on board, and you should be, philosophically, using that weight to ensure that the aircraft has all the systems and all the safety required that you would never have to use that. So it goes into the redundancy of all the other systems.
And again, you're building a commercial vehicle. You're not building, whatever. I don't even know if you put parachutes on private vehicles, but there's not parachutes on like your Delta flight.
No. But they have them. Like there's a Cirrus aircraft that's a 5-seater that has a parachute and effectively is used relatively surprisingly.
To be clear, we're talking about the parachute for the vehicle,
Yeah.
not for the
Yeah.
passenger.
Yeah.
Literally a hatch at the top, and the whole thing,
Yeah.
a big chute helps.
But
it.
here the philosophy is the aircraft should be safe enough that it doesn't require one, because there are so many other alternatives. Whether it's redundancy of the system or the reserves that allow you to divert to somewhere else, you should never have to use it.
Yeah, right. Six-rotor design, all those type of things.
Yeah.
All right, so I'm trying to infer because you kind of dodged the Super Bowl commercial. To Johnny's
I can't
point,
afford one of those.
well, you got a lot of money.
Delta
Toyota's got
and
deep
Toyota,
pockets.
you should be able to afford all kinds of Super Bowl ads.
And we are kind of coming in. I can't believe it's almost going to be September here. I'm trying to think of like major sporting events. Major moments, right?
Well,
like,
you know what I really want to nail is the Formula One. I think so. Formula One
who doesn't?
Yeah,
Yes.
but they've done a great job of promoting e-technology as well, right? Electric technology. They always have a flyover. So I would love to go down the final straight of an F1, let's say like in Vegas or.
I was going to say November. It's coming up quick.
It's
You
coming
gotta
up
get some pilots in there.
So here's the problem,
Yeah.
guys, is, it's really exciting. We would love to do that. But one of the reasons that people love watching a flyover at any kind of sporting event is because you get this like, right? That's really exciting. But all you get with us is like, you get tiny little noise.
But can you spit colored smoke out the back?
Yeah, I think we could do that for you.
Because they did this at the Quail during Car Week. Excuse me.
Yeah.
They had red, white, and blue smoke coming out of the back of some fighter jets. So.
Well, yeah. Maybe we should fly into the Quail. Maybe that's the answer.
You should.
Yeah.
You
Dude,
should land
that's
on the
the-
lawn
I
at
mean,
the Quail.
Yeah.
That's a moment.
You
should land on the orb, on that giant eyeball thing at the Vegas Grand Prix. Just land right on top of it. There's another one. This is free consulting for you, by the way.
But I would say one of the big problems with Car Week, and this is a very small business case, but there's lots of events like this where a small town is taken over by a lot of people. Is traffic. I mean, it's terrible, and it's a bummer about Car Week. It'd be great, a bunch of golf courses, great place to land vehicles.
Yep. I mean, take the Formula One. I went to Silverstone last year, and there are more helicopters in and out of there than there are almost any other event.
It's wild.
We can fix that. We'll make it cheaper. We'll make it quieter, more environmentally friendly.
I'm going to Goodwood Revival in a week. God, it's already in a week. And we go. That's how we get there is via helicopter. That's how I have so much experience commuting in helicopters. But that's how you do it. But again, I mean, they're noisy. They're expensive.
I went in an MG Roadster. That was basically all I've ever achieved.
Well,
I'll take a helicopter.
But again, I could see a lot of but you don't want a lot of helicopters landing near people.
Right.
But if they're quiet. All right.
Should land on Lord March's lawn.
You mean the Duke of Richmond?
That's
Lord
right.
March is Charlie and his son. Come on, Ed, keep up.
Sorry, Duke of Richmond.
Duke of Richmond.
Well, this is great.
Can't take it anywhere. Not just because of the COVID.
I haven't been to. You go to Goodwood every year. I haven't been in like years.
Oh, you should,
Revival. Angus is going. It's gonna be a party.
Yep.
I actually grew up just down the road from there. And,
Did you?
Yeah, I used to go as a kid, and it was one of the things that I used to love going every year. Go along. We used to dress up as well, right? Because
Revival, you dress up. Yes, yes.
That was the embarrassing bit, but the cars phenomenal.
Cars are great. It's a good time. It's a good time. Yeah. Well, cool. Well, very cool.
So,
you want to?
this was awesome.
Yeah.
Yeah.
Do you have any other burning? My thing is like, when can I get in one? Let's I want to. So, but you're saying 2025.
2025. Well, hey, I mean, there might be some people that get in one before we do commercial service.
I know a guy.
I know a guy. I mean, hey, we missed out the opportunity of bringing you all in when everyone was up in Monterey. So.
Well, hey, you know what? We're there all the time. We're close by, and like I said, we are doing a story. I don't think Scott would mind me spilling the beans because there's so many EV startups in California, not just like Tesla and Lucid and all that, but like scooters, bicycles, air taxis, which I'm never going to use EVTOL again, whatever, EVTOLs, all these things, boats. And so, I think maybe, we can start the conversation there. But anyways.
Let's do it. We won't be the second passenger on your vehicle.
Okay, you'll be the first. Okay,
but we'll be
brave.
We'll be first. I recommend Johnny for that,
or Scott. Scott.
Yes. He's been talking your ear off about how many helicopter rides he's had, so he's clearly.
I'm not afraid of flying, and I'm not afraid of new technology.
Zing. Yeah,
Ed is.
not at all. But no, this was great.
Yeah.
Oliver Walker-Jones,
Yep.
thank you so much.
Thank you.
You are the, oh boy, here's your title. It's long. It's impressive. Marketing, communications, and brand leader at Joby Aviation. Very kind enough to fly down and talk to us all about electric vertical takeoff and landing
Air taxis.
taxis,
Air taxis.
and what's
Nailed
coming
it.
from Joby in 2025.
And good luck.
Thank you. We've got a lot of work to do, but we're very grateful for your help. I'll probably leave you with a.
Yeah.
There's a quote from a famous aviation guy, Otto Lilienthal. He was in Germany 100 years ago, but invented one of the first aircraft, and his kind of words of wisdom were: to invent an aircraft is nothing, to build an aircraft is something, to fly an aircraft, everything.
Right.
That's where we need to get
All
to.
right.
See you in 2025.
On that note, thank you very much.
Thank you.
Thank you.